we can give people a good conversation. Yeah, see this here? Right here was the mistake made. So we are doing it again because we made, I made a mistake actually. So I'm going to apply Laplace transform on this, right? Okay, so
Yes.
this is Ly double prime, right? Which will
Yes.
be S square Ly minus, S times y at 0 minus y prime at 0. So this will simply be S square Ly, right? Are we good? Okay.
Yes.
Okay. Now what happens is this, we have to write L, or Laplace transform of Ly prime, right? T times
Yes.
Ly prime. So this will be what? This will be negative 1 to the power n, right? Then dds times, I'm just
Sir,
writing, yeah, go ahead.
there's no y prime in the formula.
Oh, I see. So y prime is here. I brought that from here. See that here?
Yes.
Okay. So instead of f, excuse me, what I have here is I have y prime, right?
Okay. Oh,
Is that making sense?
okay.
Instead of f, I have y prime, right? Okay.
Okay.
So what w will be? W will be L of y prime, wouldn't it be, right? That's what it says, right? Because I took big Fs as W. Or let me write that as big Fs. Nothing wrong with that. Sorry about that. Yeah. So this is big Fs, ds, and here it's Fs. Do you agree? Because
Yes.
instead of F, I have y prime, right? And I know who is Ly prime. Ly prime is how much? S
S.
Ly minus y at 0, and y at 0 is how much?
Zero.
That's a 0, right? So
Yes.
one thing is there when I'm taking an exam or something and I should be wearing my glasses, I should wear them. I didn't wear them and I just didn't see that F correctly. That's why I made that mistake, right? So what happens is this is so this quantity will be what? L of T y prime will be negative 1 to the power 1, which is just negative 1 times dds of s times. And what did we take for L of y? We took another symbol. Let's call that u, in order to solve it correctly, right? Are we clear?
Yes.
Okay.
Yes.
So this is what? S U here, right? Are we good?
Yes.
Okay,
Yes.
very nice. And so what we have now is, thanks for your patience, okay? All right, on all this. So here, what we get now for this is 2s square Ly, right? Then as a
Yes.
Laplace transform of this, I get minus sign. And then ds, and then what? Su, right? And then
Yes.
minus 2 times Ly, right? And Ly, let me write Ly as Ly, that's okay. And on the right hand side, we have Laplace transform of 18, which will be 18 over S, right? Are we good?
Yes.
Okay. So we have this, right? Okay, good. So this is 2S square, Ly is U, right? Okay,
Yes.
because that's what we chose it to be. And this is going to be minus, we are just using the product rule here. The derivative of S is 1, then minus S du ds. Are we good? And then
Yes.
minus 2u equals 18 over how much? S, right? Are we good here?
Yes.
Okay, very nice. So this becomes 2s square u, and then minus how much? This and this together will be negative 3u, right? Minus s du ds equals 18 over s, right? Are we clear?
Yes. Yes.
So now we will write that as a differential equation. Uh, and I'm going to make this part positive now and be very careful, especially under the circumstances that I have been making. I made a mistake in recognizing the other thing earlier. That should be negative 3u. Yes, that should be. So that will become positive 3u minus 2s square u equals 18 over s,
Yes.
right? Okay. So then what we are going to do now is that we are going to transfer to a noise screen, okay? All right, new share, this one. So now we have S du ds, sorry, ds, right? And then we have, I'm just writing it from here, plus 3u, okay, minus 2s square u, okay, all right, and
Yes.
that equals 18 over s, am I right?
Yes.
18 over s, very nice. So now we will divide by s, right? So let's just go ahead and divide this whole thing by s so that we can get this in the form of a linear equation. Okay, so
Yes.
we got this 3 over s, and then we have 2s squared. So when we divide that by s, that will simply be s, and this will become how much? S
That's square.
squared. Are we good?
Yes.
Okay. And yeah, now we are getting things under a slightly better control. So this would be what? This will be 3 over s minus 2s times u equals that. Are we clear on this? Right?
Yes.
Okay. So now the integrating factor will be, first let's just compute the integral of this, right? Okay. So the integrating factor is 3 ln s, right? Are we good? Because,
Yes.
okay. ln of s, okay, and then minus simply s square. Am I correct?
Yes.
Right, good. So minus s, not integrating factor, that will be the power on that, right? So
Yes.
the integrating factor will be what? E to the power all this, right?
Yes.
So that becomes this. Oh, this will be what? S cubed, right?
Yes.
Okay, and this is going to be e to the power this minus e to the power, no, not my times actually, e to the power negative x s square. Am I right?
Yes.
S square. So that will simply become, this part will become s cubed, right?
Yes.
This is s cubed and this is e to the negative s square, right?
Yes.
So that's for this linear equation, right? So what the solution will be then? U times this quantity, right?
Yes.
Equals the antiderivative of this quantity, right?
Yes.
Times this quantity ds, okay, and of course plus a constant, right? Okay.
Yes.
So just a second, plus a constant. So that gives us, what will that give us? This is a little, so here we have 18, right? We factored
Yes.
it out and let's divide it. So this will become what?
One. Yes.
Simply n s, am I right? Right?
Yes.
Okay. So this whole thing becomes this, right?
Yes.
And this guy, if you use the substitution rule, wouldn't that be negative 1 half e to the negative s square?
Uh,
See, if I
yes.
use, right? So that will be negative 1 over 2 e to the negative s square. And then we have an 18 here, right? So that will make it negative 9. Am I good on this? Right?
You took s square as u, right?
A negative s square as u, right?
Yes.
Okay. So
Yes.
that will be 1. So in that case, 2s ds will be du. And you can just extract a 2 from this or divide or whichever way you do. That's what this will be, right?
Yes.
Are we right?
Yes.
Okay. So that means that our u is going to, okay, let me just write this again here. Write this, okay. So then my u is going to be, so when I divide this one by this bracket, e to the negative s square will cancel, right?
Yes.
Make sense? So what would I have? Negative 9 over s cubed, right? Are we
Yes.
clear?
Yes.
Negative 9 over s cubed. So, and then, and then plus, then what I will have, I'll have a c here, right? Okay, and when you divide by that, that will become e to the, okay, let's just write it like this, s cube, right, divided by how much? Not s cube, sorry, c divided by this quantity, right? Make sense? Or
Yes.
in other words, what will happen is this is L of y, right? Remember that? This
Yes.
guy is L of y. So let me get my symbol for L back. Yeah. Y is this, right?
Yes.
And or in other words, we may do this also, that this guy here can be brought upstairs, right? E to the s square, right? Now, see, Laplace transform, it has one property, okay? Uh,
Yes.
and the property is this, and it should be in one moment. Let me just bring this here. That is, no, this is not it. Let me just bring the Weber sign. Where is Weber sign? Here. Okay, let me bring Weber sign so that you can see that that property is available to you. Okay. I think I just lost that page somewhere. View as a student. No, not this, sorry. So we go here and we have these here, right? So see this here. If you let s go to infinity, right, then
Uh-huh.
Laplace transform should be what? That should be a zero, right? Am I
Uh-huh.
clear?
Yes.
Okay. So what happens is this. So since limit as s goes to infinity, of Ly has to be zero, all right? So what we have is this, that only way this can happen is when this guy c is zero, right? Are we clear?
Yes.
Because e to the s square over s cube, that will just go to, that will just go to infinity, okay? Am I
Yes.
clear? So
Yes.
that's the only way. So c must be zero, right?
No, Professor,
Go ahead.
why should it be zero?
Yeah, because what happens is this, if you let s go to infinity,
Yes.
the limit of this sum should be zero, right?
Yes.
So you can see this, that this guy goes to zero without any problem, right? Am I
Yes.
clear?
Yes.
But this one is this here. That is, this is c times, sorry, c times this guy here, right? Am I clear?
Yes.
Now
Yes.
this goes to infinity as s goes to infinity. You can use
Yes.
L'Hopital and see. Okay, all
Yes.
right. So that goes to infinity. So what is going to happen now is this, that in order for this to be true, I can't have any c over here, right?
But Professor, even if C is any other number, it won't matter
It will
because it's
matter because if it's a non-zero number, then as s goes to infinity, see this here? This guy, let's see, let's use L'Hopital repeatedly here, okay? See this? So I'm writing like 2s over here. I have 3s squared, right?
yes,
Makes sense? So again, I have to use L'Hopital, right? And can I
yes,
just keep doing calculation here side,
yes,
along with? This
yes,
becomes this, right? Then
yes,
when I use L'Hopital again, it becomes what? 2s e to the s square, right? And downstairs is 1. So doesn't it go to infinity, right? So if
yes.
c is a non-zero number, then what will happen? That will go to either positive infinity or negative infinity, depending on the sign of c, right?
Oh,
Okay.
okay.
So by that rationale, we must have c equal to how much?
Zero.
0, right?
Yes.
Okay. So, so this is zero. No, not this is not 0. Sorry. Okay. Okay. This becomes this, right? Are we clear?
Yes.
So y is how much? Inverse Laplace of 9, negative inverse Laplace of 9 over s cubed, right?
Professor,
Uh-huh.
why do we only have 9 over s cube?
Oh, because of this. C
Uh,
will had to be 0, right?
oh, okay, okay.
Okay, makes
I understand.
sense?
Yes,
So, and what is so what happens? Laplace transform of t square was how much? 2 over s cube, if you remember, right? Or that table
yes,
is just given to you. You don't have to memorize it, but you can see this, that this guy is how much? 2 over s cube, right? Am I
yes,
clear?
yes,
So inverse Laplace of 1 over s cube will be t square over 2, right?
yes,
So this will become how much? 9 t square over how much? 2, right?
yes,
So that's the second part of the solution, right?
yes,
Are we good on this?
yes.
So we can meet again probably on Wednesday sometime. All right.
Okay,
Okay. Or just ask me for another appointment. Okay. All right.
okay.
Okay. Very good. And thanks for your patience during all the commotion that I had in between. Okay.
No problem.
Okay. So let me just first stop recording here.